Alright, good morning, my Core 1 peeps. We are going to go through a review from before spring break, which is kind of a going through the distributed property, and then after that we are going to talk about how to factor an incomplete quadratic. So I'm not giving you a specific note sheet, but I would love it if you would follow along and jot down these examples and jot down any ideas brought up in this video. So really practice your note-taking skills here, as this will be directly applied to an assignment today and tomorrow on Delta Math. So just to start, let's review what the distributive property is. And that is that if I've got, if I've got A times B plus C, that's the same thing as A times B plus A times C. So if I do that with the example problem I have above, I've got x times 3x minus 15. I need to distribute the x to the 3x and distribute the x to the negative 15. Notice that there's the negative sign there. So this is going to be x times 3x, that is 3x squared. And x times negative 15 is negative 15x. And right there, we've got our simplified distributed expression. So what factoring is it's undoing the distributive property. So if I were to take and erase this guy, if I were to undo that, what I'm doing in factoring is I'm taking out the greatest common factor. You're going to hear us say that a lot. The greatest common factor. I'm going to factor out that greatest, or I'm going to divide out that greatest common factor from each of these terms, from the 3x squared and from the negative 15x. So if I'm factoring that out, I got to think about what's the greatest common number, and also what's the greatest common variable between each of these terms. So 3x squared is its own term, negative 15x is its own term. So how do I figure out what's common between the two? Well, let's focus on the numbers first. What's the greatest common factor between 3 and 15? Well, you could divide both of them by 1. You can't divide them by 2, but you could divide them both by 3. 3 divided by 3 equals 1, and negative 15 divided by 3 is negative 5. So we obviously can't go any higher than 3, because 3x is the highest factor that you could have is itself for 3. So the greatest common factor we're going to factor out is going to be, in this case, a 3. Now, looking at the variables, well, we could factor out, we've got an x squared and we have an x. So what's common between the two? Well, they both have a single x, but x squared has an x times x. And so that's x times x. Right here it's just a single x, but they do have one x in common. So we are going to write x as the next common variable. So what's common is 3 and x. But now what we're going to put in parentheses is left over once we have divided those numbers out. So now what we have to do is focus on each of these terms and say, okay, what happened when I factored a 3x out? Well, what's 3x squared divided by 3x? Well, 3x squared divided by 3x, well, the 3's cancel out, and if I have an x squared on top and just an x to the 1, right, remember just x is x to the 1, I'm left with just x over. So what's left in the first guy is x, and then if I do negative 15x divided by 3x, well, negative 15 divided by 3 equals negative 5, and x divided by x is just Those cancel out. So I'm left with -5. And that is how you would factor this outwards. What you'll notice is that this guy right here and the thing that we started with are not the same looking, right? They don't look the same, but they are equivalent to each other. And what I did here is actually a more simplified way of factoring this incomplete quadratic. So that's an example. And now this is kind of an example of where we would do the distributive property one way and then how we could undo it and factor it again. I'm going to do another page. So now what I'm going to do, sorry, I think I got cut off there. We're going to go to a new page. I believe I can do another page. Oh, here we go. I'm going to give a couple of example problems of just factoring. We're not going to distribute or anything, we're just going to factor. So the first example is 3x squared plus 9x. So what is that equal to? What's that equivalent to? Well, first, what's the greatest common number? And then second, what's the greatest common variable? So first, if we look at what's the greatest common number, well, 3 and 9. If I have 3 and 9, the greatest common factor between 3 and 9, well, they're both divisible by 1. They're not divisible by 2. Are they both divisible by 3? And you should be saying yes. They are both divisible by 3. Now, a factor can't go any higher than the smallest number. So 3 is our lowest number. In terms of the greatest common factor, we can't go any higher than 3. So 3 is our greatest common number. Now, what's our greatest common variable? Well, the greatest common variable, if we look at x squared, we've got an x times an x. And if we look at just our regular x, we just have a single x. What's common in both of those? A single x. I only have one x here, but I have 2 here. Well, the greatest common factor of those is just a single x. So we will go with that. And I'm going to erase that. So now that we have done that, we're going to have something left over in parentheses because I need to factor out 3x from each of these guys. So if I do 3x squared divided by 3x, kind of like what we had before, the 3's cancel out, and then I'm left with an x squared divided by x, which leaves me with a single x over afterwards. Now I need to take 9x and divide it by whatever we factored out. Again, we factored out 3x, so we're going to divide it by 3x. Well, the x's cancel out, they're eliminated, and 9 divided by 3 is 3. So I'm left with a positive 3. So this would be my final answer. 3x times x plus 3. That's how you would factor that one. Now pause this, ask questions on the Google Doc for office hours if you have questions, but otherwise we're going to move on to another example. Example 2. Let's say I have 2x minus 5x squared. What is that equal to? Similar fashion. What's the greatest common number? What's the greatest common variable? Well, if I look at my numbers, 2 and 5, well, they've got 1, right? They're both divisible by 1. And the 2 is divisible by 2, but the 5 is not perfectly divisible by 2, right? 5 divided by 2 is 2.5. We want whole numbers to be resulting from this factoring. So 2x minus 5x squared, 1 is the greatest common number. I will put a 1 here to humor you, even though that really doesn't have to be there. Now let's look at the greatest common variable. We've got an x and an x squared. like you guys have seen in the previous examples, the greatest common variable between those two is, well, there's an x shared in both of them. There's an x squared here, but there's not an x squared here. So the greatest common variable is just x, so a single x. But then it's going to be times whatever's left over when we factor those out. So if we're factoring out an x, 2x divided by x, well, the x's cancel out and we're left with 2. If I've got, for my other term over here, I've got negative 5x squared divided by x. Well, negative 5 divided by, well, there's really a 1 here, an imaginary 1. Negative 5 divided by 1 is just negative 5. X squared divided by x leaves me with a single x. So I'm left with negative 5x afterwards. And that is my solution. That is how I have factored my incomplete quadratic. So in this case, these are going to help us move towards some type of solving of quadratics eventually. Don't worry too much about what that means right now. We'll get there eventually, but here's a couple examples. You guys are going to need to know how to do this for the assignment tomorrow. And to help you practice that, your Delta Math assignment is going to be having you practice finding the greatest common factor between two numbers. So for example, I'm going to say, let's say we've got the number 22 and we have the number 54. What's the greatest common factor between the two of those? Well, is 22 divisible by 1? Yep. Is 22, or are both of them divisible by 1? Yep. Are both of them divisible by 2? Yes, they're both even numbers. Are both of them divisible by 3? No. What about by 4? This is where it's handy to have a calculator out. 54 divided by 4 gives us a decimal. 22 divided by 4 would also give us a decimal. So that's a no. 4 is a no. What about 5? Nope, 5 won't work because that's an odd number. In this case, these are not multiples of 5. Would 6 work? Well, 6 does not divide into 22. Would 7 work? It doesn't. 7 doesn't go into 22, and but 7 does go. 7 does not go into 54. Well, I don't think so. Nope, I was thinking 56, my bad. And we can kind of see that this pattern will continue. So then you need to think about, okay, what are the big, like what's half of 22, or what's half of 54? Or another thing to always look for is, can I divide 54 by 22? Well, 54 divided by 22 ends up equaling 2.45 repeating. So that will not work. So it looks like 2 is going to be our greatest common factor between these two numbers, which seems really sad because these two numbers are really big, but the greatest common factor between the two of them, right? What are these two numbers divisible by in common? The greatest common thing is going to be a 2 here in this case. So quite disappointing and lackluster, but it is what it is. Now, what I would like is for you to go ahead and work on that Delta Math assignment. Please, please, please ask me questions on the office hours document, especially on Thursday when you have an assignment where you are going to actually be factoring like you did for this example, and our first little walkthrough. But we will be in contact, and I'm very excited to see what you guys are going to learn and get better at. So thanks, guys. I hope that your break was really good, your spring break was really good. I'm saving this little piece for the end because you can choose to listen to it if you want, or you can choose to work on your assignment. I will not be offended either way. But anyways, I hope that you were able to set school aside, focus on just relaxing, and focus on doing something that is personally enjoyable to you. I hope that you guys had a really, really incredible Easter, just remembering just the incredible gift that it is that was given to us by our Lord by sending His Son to die for us. So I really hope that that's been a focus for us all. I'm noticing that I'm at 15 minutes now, and I should probably end this. So thank you guys for tuning in. I will definitely be talking to you guys later, and yeah, have a good, awesome day.